Okay, so we were discussing how we can perform de-risking strategies. Okay, so we took the following example. Let's say we have a certain reference, if you want, method to produce electricity. And this method, let's say, is combining coal, diesel, oil, and hydropower. And we were able to reach, using this reference case, a very acceptable price in USD per kilowatt hour. And we want to invest now in a new renewable energy project. So first, we take the renewable energy project in the initial stage. This is what we call pre-de-risking. So before implementing the de-risking measures, okay? And we estimate for this case what will be the total renewable energy cost in USD per kilowatt hour. Once we do this, we have a certain gap between the cost that we have compared to the cost in the reference case. So we say we want to implement several de-risking strategies in order to reduce the cost in USD per kilowatt hour of the renewable energy project to make it competitive with the reference case. And this is what we will do through implementation of several de-risking instruments that will help to reduce risks related to the renewable energy project in order to make it competitive with the reference case. So even if we are not able to reach maybe the same level, at least when it is comparable, even if we have a little bit higher USD per kilowatt hour cost, but we know that whenever we have a renewable energy project, we have a lot of advantages because it's clean, it's renewable, etc. And plus, whenever we implement these strategies and we make the price competitive with the reference case, we can also impose, let's say, some taxes, additional taxes on the reference case because it's using diesel oil in order to make the renewable energy project more, if you want, even economically more viable, because it will allow us to avoid paying any taxes related to CO2 emissions. So whenever we put our targets, we can go and find what should be the different instruments to implement, and we can construct the diagram of de-risking by finding, calculating for each implemented strategy how this will affect the cost, because each strategy implemented will reduce the cost in USD per kilowatt hour of the renewable energy project. Now, of course, whenever we want to perform de-risking, we need to do sensitivity analysis because we might need to determine what is the impact of each factor on our project. So we can, for example, fix some factors and vary one, as we did already, if you remember before for the financial and economic analysis. So we can see what is the effect of the discount rate on the project, for example. Here we can say if we implement this factor or if we combine these factors, what will happen? Because you need at the end to select some instruments. You have a lot of possibilities and a lot of choices, but we need to determine what is the best combination of instruments in order to have an optimal de-risking of your project. Okay, so here, for example, in the sensitivity analysis part, we should analyze the selected or public instruments in terms of 4 key performance metrics, and we should perform sensitivity analysis on key inputs and assumptions. And for example, if we consider that the main outputs are the investment leverage ratio, the savings, the affordability, the carbon emission level, so we can then, based on these 4 performance matrix, determine what are the most influencing parameters. So for example, when we do the sensitivity analysis, let's say, we can calculate the investment leverage ratio, cost of public instruments, and renewable energy investment. So the investment leverage ratio can be used to compare the effectiveness of different instrument sets in attracting a certain amount of private investment. The savings leverage ratio isolates the cost of the newly introduced de-risking measurements. The cost of these de-risking instrument is then compared with the difference between the pre and post de-risking incremental cost. As the de-risking instruments cost as well as the saving occur over time, the present value of the costs and savings are used to calculate the savings leverage ratio. What we mean by this, we know حتى when we implement instruments, this needs money. And we need to put additional cost to implement measurements in our project. But we know that implementation of these measures will lead to increase of savings, and this will help to modify the use of the renewable energy project. But of course, we should make sure that the savings should be larger than the cost of implementing the instruments. If not, then it's not efficient to go through this de-risking instrument. Okay, so you should always make sure that the cost of implementation of these measures is smaller than the savings they will lead to. And the framework's third metric is the end user affordability. It will take an electricity consumer perspective and will compare the generation cost or levelized cost of electricity, for example, of wind energy in the post de-risking scenario versus the pre-de-risking scenario. Now, if we talk about the abatement costs are calculated by dividing the present value of the incremental cost of the renewable energy project by the abatement potential. So these are, if you want, we have seen here four, if you want, numbers that will help us into assessing the feasibility of implementing a certain de-risking instrument and how it will affect in overall our project. Here, for example, in this slide, we illustrate the impact of risk categories on financing costs for wind energy and solar PV investment in Lebanon. So we try to see, for example, to compare, let's say, the diagrams for wind and solar energy. And we compared, let's say, here, the best-in-class country has a risk, an associated risk of, let's say, 7%, while for Lebanon, it's 16% because of the high number of risk categories, including the power market risk, the social risks, the development risk, etc., the political risks. And now, once we get the overall risk, what we should try to do is to implement several strategies to decrease this high risk amount. Okay, and this is the constructed one for solar. So this was the chapter of de-risking. Now we will move to the last chapter in this course, which is how to develop multi-criteria decision-making analysis. And you have already, if you want, a basic knowledge about this because you use the decision matrix in your project. You know how we put scores, how we normalize scores, how to find the best option. What is only missing for us is how to determine the weights, and we'll discuss this in detail in this lecture. So we know that whenever we have a project, we might have several alternatives, okay? And each alternative can be, if you want, can have an advantage over the other alternatives. And then how to decide what is the best option? We need, as we said before, we need to develop a decision matrix. This decision matrix will be the framework where we include different factors, social, environmental, and economic. So for example, here, option A is the best between options if we talk about environmental impact, but option B is best if we consider social impacts, and option C is best if we consider economic impacts. Which one to choose? So to be able to answer this question, we can build the decision matrix, we can put scores, we can determine weights, and based on this, we can make our final decision. So multi-criteria decision analysis is a sub-discipline of operational research that explicitly evaluates multiple conflicting criteria in decision making. So we know that we have, especially if we add social to environmental to economic factors that might have very different units, how we can take into account all these conflicting criteria to make the decision. This is what is done through the multi-criteria decision analysis. So MCDA is both an approach and a set of techniques with the goal of providing an overall ordering of options from the most preferred to the least preferred option. The options might differ in the extent to which they achieve several objectives, and no one option will be obviously the best one. We already discussed this in your project. So whenever you compare several alternatives, the decision matrix can help you into downsizing if you want your project. You can say, now I am left with 2 or 3 alternatives that gave me good scores in overall, but now to decide which one to go through, I might do an extensive economical analysis to compare them and to decide on the best option. So the decision matrix is not the only tool that should be used to decide on the best project. It is a tool that can help us into, if you want, selecting the good alternatives, and further analysis can help us to decide which one is the best. Uh, the options may differ in the extent to which they achieve several objectives, and as we mentioned, no one option will be able to achieve all objectives. So in addition, some conflicts or trade-off is usually evident among the objectives. So options that are more beneficial are also usually more costly, and this is why we need to perform decision matrix analysis and economical analysis. Plus, we can do more. We do, if you want, analysis on several aspects, on the environmental level, on the social level, on the economical level. Our decision will be better. So MCDA is a way of looking at complex problems that are characterized by, first, the mixture of monetary and non-monetary objectives, of breaking the problem into more manageable pieces to allow data and judgments to be brought to bear on the pieces, and reassembling the pieces to present a coherent overall picture to decision makers. The main purpose is to serve as an aid to thinking and decision making, but not to take the decision. So this is what we talked about. It can help us into, for example, if I have 10 alternatives, the decision matrix can help me to select 2 or 3 alternatives that should be compared in a more extensive way by conducting comparison on different levels. Now, what are the main components of the MCDA problems? So first, of course, we should determine the decision makers. So the first element is to identify the decision makers. If you remember, a lot of you in your projects told me that the weights were decided based on the owner. So I should ask if I'm considering a private project. So the main person will be the investor or the investors, and they will decide mainly on the weights they will consider for the different factors. So for a particular problem, we might have a single person who is responsible for deciding what to do, or several people or organizations being involved in the decision-making process. And in general, whenever we have a project on the public level, the number of decision makers is much larger because we should take a society-wide view to consider the weights of different factors. Now, for the alternatives, these are the possibilities one has to choose from. Alternatives can be identified or even developed, created where they did not previously exist. And this is research. So whenever you confront a new problem, you might have to come up with an original, let's say, system to be able to solve your problem. And in case your problem was already solved before, you can do some research in other countries. What are the main ways to tackle this? How can I implement them to solve my problem, etc. And we already discussed this in the first chapter of the design steps. Now, concerning the attributes or criteria, these are the characteristics or requirements that each alternative must possess to a greater or lesser extent. So, depending on the project, in the decision matrix, we can consider, as we said, several factors, including environmental, social, and economic, so like the cost, the maintenance, the income, the noise effect, for example, the percentage of CO2 emissions, etc. So this is what we already know well how to do because we used it to be able to decide on the best alternative in the project you did. So the performance matrix is a standard feature of multi-criteria analysis. It is a performance matrix or consequence table in which each row describes an option and each column describes the performance of the options against each criterion. Now, one of the most important parts is the scoring and weighting, okay? And we have already discussed together how to put scores. So for any, let's say, factor, we determine what is the best value. Yeah, for example, if we are considering the dollar per kilowatt hour, okay? Of course, if I am, let's say, if I'm considering the point of view of the owner of a power plant, for the owner of the power plant, this is an income. So the largest value is the best option. While if I take, if you want the point of view, let's say, of a person that wants to buy electricity, okay, for this person, the smallest value will be the best. So we should always know we are doing the analysis relative to which part, okay, in order to determine if this value is a worst case scenario or best case scenario, okay? So for example here, if I'm considering the person that wants to buy electricity, of course the strategy characterized by the smaller cost of electricity per kilowatt hour is the best one, and the worst scenario is the highest price. So here, all we have to do once we determine the best value and worst value, any of the value to get the score, if we want to put the score on 100, we just have to do 100 times worst value minus observed value over worst value minus best value. And then by multiplying by 100, we get the scores from 0 to 100. We can put grades on scores on 1, on 10. It doesn't matter. Just you select a scale, and based on the scale, you should put all of your scores. So scoring is the expected consequences of each option and are assigned a numerical score on a strengths or preferences scale for each option and for each criterion. More preferred options will score higher on the scale and less preferred options will score lower. In practice, scales extending from 0 to 100 are often used, where 0 represents a real or hypothetical least preferred option and 100 is associated with a real or hypothetical most preferred option. All options considered in the multi-decision criteria analysis would then fall between 0 and 100. And in this way, we will normalize numbers from 0 to 100. Now, the second important factor that we will discuss in this lecture is how to put weights. Weights are very important because not all factors are of same importance. So weighting consists of numerical weights that are assigned to define for each criterion the relative valuations of a shift between the top and bottom of the chosen scale. What we mean by this, if for example, let's say the social factor are more important than the economics, they should have a larger weight, okay? And how to decide for the weights? Now we'll develop a calculation method to put weights. So the main stages of typical decision-making problem are first, to identify the decision maker or decision makers. Second, to identify the alternative courses of action. Third, we should identify the attributes that are relevant to the decision problem. Fourth, for each attribute, we should assign values to measure the performance of the alternative on that attribute. Then we should determine a weight for each attribute. After this, for each alternative, we take a weighted average of the values assigned to the alternative, and then we can make a provisional decision based on the obtained scores. And finally, we can perform a sensitivity analysis in order to decide on the best option. So now we are taking here the example, let's say, of electricity generation. And we have already discussed a lot such things. And we want to reduce, if you want, the electric consumption, the cost of electricity. In order to reduce the cost of electricity, we need to compare several strategies. And here we know we have several possible sources. We have the conventional sources using fossil fuels. We have the renewable energy strategies, solar, wind, hydropower, geothermal, nuclear. We have a lot of possible strategies to produce electricity. Now, in order to compare them and to do a decision matrix to select the best one, we should consider, as we mentioned, several factors. In this table, they already gave you the weights, and we'll discuss in a while how to determine these weights. Whenever we want to compare several strategies, as we said, we need to consider several factors. And sometimes, okay, we have studies done on larger scale in several countries that can help us to know, in general, what are the factors that have a high impact. So this is, of course, based on large statistics done on a large scale. So, for example, if we want to implement any electricity project and we take the technical criteria first, what can be the technical criteria that can help us into making the decision? We have the efficiency of the project, the reliability, the resource availability, the nominal power per installed capacity, the maturity, the energy production, the safety, the demand, etc. All of these factors are important as technical criteria. Now, we can put, like, if you want, international weights based on, as I mentioned, large statistics done. Of course, these weights can vary from a region to another. Okay, so let's say maybe in America the weights will be different than in Europe, different than in Arabic region, etc. But for each region of countries that have, if you want, similar factors, we can consider similar weights. So here, this was a study performed. Okay, it's an evaluation criteria in energy policy and planning, and we are suggesting using the following weights for the different technical criteria. And since we can expect that efficiency is since efficiency is very important because it will reduce a lot the energy consumption, it is characterized by the largest weight among the different factors. If we consider, let's say, the economic criteria, what are the criteria that can be considered as economic? We can consider the payback period, the energy cost, the investment cost, the operation and maintenance, the internal rate of return. All of these we already know how to calculate them and how they contribute to the economic analysis. And as expected, one of the highest weights is for investment cost, because we know that this cost is not discounted, and it will make the largest proportion of costs in general, especially in renewable energy projects. Okay. Now, if we consider, let's say, the environmental criteria, we have several factors that be considered, and the CO2 emissions is, as expected, the most important one with a very high weight, in addition to other factors as land use, impacts on ecosystems, NOx emissions, CO2, SO2 emissions, etc. Also, for social criteria, we can divide them into several parts as job creation, social acceptability, social benefits, impacts on health. And also, we know that people are in general interested into creating jobs vacancies. That's why the highest percentage is for job creation. So, for example, in each region, we can do statistics to decide what are the weights that should be given to each of the factors considered in the overall study. So this is an example in energy planning where we consider all possible criteria, including financial, environmental, technical, and social. And we want to apply, let's say, on it, the analytical hierarchy process, and we want to determine the weights, okay? So as usual, let us now develop the method of calculation that can help us into putting weights for each criterion. This is called the analytical hierarchy process developed by Thomas Sati in 1970. It consists of the following. And of course, it's not the only method to put weights, okay? We have already together now in the previous chapter, when we consider de-risking instruments and de-risking factors, we were able to develop a method in order to decide what is the weight given to each risk instrument or risk category. So this is another technique. So we don't have one possible way. We have several possible techniques to put weights. But this one was really efficient because, as we will see, it will compare, if you want, factors one by one. From here, its importance. Okay. And what is the idea of this method to put weights? First, it is based on paired comparisons. So I compare each criterion with the other criterion. So I will ask people, if you want to compare, let's say, noise effect with CO2 emission, which criteria for you is the most important? And he will give me a certain score. And now we'll discuss how we put scores, okay? And then I will compare now noise with the investment cost. And I will compare this effect of noise with all other criteria and put scores on this. And I will repeat this. So I will do 2 by 2 comparison until doing all possible comparison. This is why we say when we perform this method, the total number of pairwise comparison is A times A minus 1 over 2. Why? Because if you have A criteria that you want to compare, okay? So when you want to do a pair comparison, you have for the first, if you want to do it in an ordered way, you have for the first choice A possibility, and for the second choice, A minus 1 possibility. But because the order is not important, and if I ask you, do you prefer A or B? Or if I ask you, do you prefer B or A? It's the same question. I divide this number by 2 because I don't care for the order. This is why I say I need to compare A times A minus 2, A times A minus 1 over 2 pairwise of comparison to be able to find the weights. Okay, let us discuss now how to put grades, okay, and how to come up with the total weight. The paired comparison is scaled according to the following scheme. Okay, example. If I have, let's say, if I want to know the preference between different fruits, so let's say I have apple, banana, orange, etc. I have, let's say, these 3 options. Okay, so I want to compare apple to banana to orange. Since I have 3 choices, the number of pairwise comparison is 3 times 2 over 2. Why? Because as we said, we don't care for the order. Okay, so what are the 3 pairs I can do? Apple versus banana, banana versus orange, and apple versus orange. So I need just to ask 3 questions. Okay, I can ask a person the following. The first question will be, if you compare banana to apple, so I should tell him what is my reference. Okay, if you compare banana to apple, what is the score you put? I will tell him, if you extremely prefer apple, put a grade of 9. If for you both fruits are equal, put a grade of 1. And if you slightly prefer Apple, put a grade of 3. If you strongly favor it, put 5. And if you prefer it a lot, let's say put 7. Okay? So this is my grading scale. And no need to ask him again. I don't need to tell him, if you take as reference banana, what is the score you will put for apple versus banana? Why? Because once he will give me, let's say he will tell me, I prefer apple and I will put a score of 9. This means that when I compare, when I take the reference as banana versus apple, I can say that the score is inversely proportional to 9. It's 1/9. Okay, this is why I don't need to ask the question 2 times. It's enough to ask it once, so to know what will be the answer if I switched the 2 options. Okay, so now we'll see together that we should always determine what is the reference. So for example, if I take now apple versus orange, okay, and the answer is 5, this means, because it's larger than 1, this means that I prefer, if you want, I prefer apple. Okay, because apple is the reference. So when the score is larger than 1, this means that I prefer apple. So now, if I can expect that if I ask orange versus apple, the score will be 1/5. It's smaller than 1 because I prefer apple compared to orange. Okay. And now we'll see how we can summarize all of these results in a table and how we can accordingly calculate the weights. Okay, so these are, if you want, the steps in order to make the pairwise comparison. So first, I should scale on the pairwise comparison. We can make the evaluation by grading each comparison with grades ranging from 1 to 9, as we discussed. And sometimes we can play with scores, and we can say, for example, we can give only these options: 1, 3, 5, 7, 9. Or if you want more accurate results, we can implement numbers 2, 4, 6, and 8 for intermediate values to be used when compromise is needed. Now, as we discussed, okay, if we have A versus, let's say, orange, and apple is the reference, and we have a score of X, then we can deduce that if we ask the question orange versus apple, the score will be 1/X. Okay. So now, for example, let us consider the following problem. Okay, we have several criteria. The criteria are the total cost of electricity, the environmental impact, the technical performance, and the social acceptability. So we have here, we have 4 criteria. Whenever we have 4 criteria, the number of questions that should be asked is 4 times 3/2. So in total, we should ask 6 questions. Okay, the 6 questions are the following: how much total cost of electricity is more important than environmental impact? How much technical performance is more important than social acceptability? How much environmental impact is more important than technical performance, etc. To not confuse, we can put an ordered method to know what are the questions that we should ask. To understand better this, let us consider the following example. So here they are putting for you, here it's much ordered, okay? We have several high number of criteria to consider. So it's not easy to determine all options. This is why I should put it in a more ordered way, okay? So I have, as we said, we have the capital cost first, which is important. We have the fuel cost. We have the fixed operational and maintenance cost. We have the variable operation and maintenance cost. we have, let's say, the land use, the water consumption. Okay, so all of these criteria are important. So now if we want, for example, as a first stage to compare these criterias, okay, we say let us fix first one criteria and compare it to all others. And I want to show you a table that is clear. Okay, this is the table that we should do. And for example, let us say we have 5 important factors. Whatever are these factors, okay? How we ask questions? We start to say, let us put factors in order. So I have factor 1, 2, 3, 4, and 5. And now when I ask the questions will be as follow. First, I do comparison of C1 versus C2. So I will ask the person, okay, can you put a grade if you compare C2 to C1? What is the grade that we will put? And I will tell him the grades are from 1 to 9. And I tell him if you prefer C1, okay, give a score between 1 and 9, where 9 is I extremely prefer C1. While if you prefer C2, you can tell me I prefer C2 and then I put a score of 7. But if you tell me I prefer C2 and I put a score of 7, when I compare it to C1 as reference, the score will be 1/7. Okay? Yani for example, now I can tell you from this table what was the answer of the persons, because always when you have C1 versus C1, it's of course 1, because when you compare the same two options, it's equal. Now, the question, the number here is the response to this question. If you take as reference C1, what do you prefer, C1 or C2? Okay, so he will tell me, let's say I prefer C1 and I put for C1 a score of 7. So here I will put in the comparison of C2 relative to C1 7. Now the question that I should answer to put the score here is between C1 and C3, what you prefer and what is the score you put. And always when I ask the person, okay, I tell him I am comparing C1 and C3. The first question will be, what do you prefer? So the person will answer, let's say if it will answer C3, okay? If it will answer C3, then when it puts, let's say, a score of 5, since here my reference is C1, I should put 1/5, okay? While when I take the line of C3 and I want to put a score here for C1 versus C3, then I put 5, okay? I will repeat this idea. So what I will give you, okay, is the following. I will answer, I will ask in the questions, okay? I will compare options. I will give you a table saying, first I will ask the question C1 versus C2, okay? I need the answer. I will first ask him to give me the preferred option. So the person that I am questioning will tell me first if he prefers C1 or C2. So for example, if he tell me I prefer C1, then I tell him what is the score you give for C1. Let's say he will tell me 7, okay? This is why here, when I want to put the score, since the preference was C1, this means that the high score, C1 is preferred on C2. So when C1 is the reference option, I put the score as it is, okay? While if he told me I don't prefer C1, I prefer C2, then the score he will give me here, the score of 8, is relative to its preference of C2 over C1. And since in this table my reference is C1, the score will be 1/8. Okay? This is